going to be exploring scatter plots and relations and functions. So let's start by looking at a scatter plot. A scatter plot is a graph that relates two groups of data. So when we have a scatter plot, we can have what's known as a correlation. There can be a positive, a negative, or no correlation. So if we take a look, a positive correlation would be when we have a scatter plot and the data all seems to have a trend line that is going in the positive direction. So this is a positive correlation, and that means both sets of data are increasing. If we have a negative correlation, it means our scatter plot has values that the trend seems to be where they're going in the negative direction. So this is a negative correlation, which means that one increases and one decreases. For no correlation, we have a scatter plot that doesn't have a trend of going in either direction. So this is no correlation, which means that they're not related. So let's make a scatter plot with the data that is given to us. We're looking at dollars spent and gallons bought. So I am going to use this as my independent variable. So dollars spent. Oops, sorry, nope. I wanted to make this my independent dollars spent. And then my gallons bought is my dependent. So how much I spent. So if I spent $10, that means I bought 6.3 gallons of gas. If I spent $11, I bought 6.1 gallons of gas. When I buy 9 gallons, I paid $5.60. These aren't going to be 100% accurate, just kind of make them as close as possible. $10 was 5.5. $13, which is going to be off the graph, would be at 8.3. $5 was 2.9. $8 is at 5.2. 5.2 is right there. And $4 at 2.7. So there is our scatter plot. And if we look, as we spend more money, the gallons we buy increases. And it seems to have a trend line that's going in the positive direction. So this is a positive correlation. And if we look at this, we could say that the more money we spent, the more gallons we bought. So which goes with our positive correlation that both are increasing. When I increase my money, I increase my gallons. So looking at each of these three trend lines, here I seem to be having a trend line where it's going in the positive direction, so this means this is a positive correlation. This one looks like it's going in the negative direction, so this is a negative correlation. And this one kind of seems to be all over the place, so this is no correlation. So would you expect a positive correlation, a negative correlation, or no correlation between the two data sets that are given to us down here? We have to explain. So the number of calories burned and the time spent exercising. So this is a positive correlation, and it's a positive because the more time spent exercising, the more calories we'll burn. Both are increasing. We're increasing the amount of exercising, so we're increasing how many calories we are burning. The length of a baby at birth and the month in which it was born. Well, that is no correlation. Because just because you were born and you were at a length of, let's say, 20 inches, that's not why you were born in February. You could have been born in February and been 22 inches long. So there is no correlation. So the baby's birth month has nothing to do with its length. If change in one quantity causes change in a second quantity, then the quantities have a causal relationship. Quantities can be related and not have a causation. So they can be related to one another and also not have a causation. So how are the following quantities related? Do the following quantities have causation? So the number of cavities and the size of an elementary student's vocabulary. So these are related because elementary students can have cavities, and they do have vocabulary. So they are related because an elementary student can have both. However, there's no causation because if a student has 4 cavities, that does not affect or have anything to do with how much they have in their vocabulary. So there is no causation. The depth of snowfall and the amount of time spent clearing the driveway, these are definitely related because when there is snowfall, clearing a driveway will occur. So they are related, snowfall, clearing a driveway, and there is causation. When the snow falls, you probably will have to clear your driveway. If you don't, you might be stuck in your driveway. So there is causation. So now let's take a look at these graphs. So we're going to label each section of the graph. So we're dealing with time and balance. So you're balancing. So when we are flat, the time is increasing, but our balance doesn't change. So here you're just staying the same. Meaning if you deposit it, so like this is looking at a checking account. Let's say this was at 50. You deposited $50 and over time you haven't put in any more, so it's going to stay the same. So here we would be making a deposit. So it's going to increase how much we now have in our checking account. Again, some time passes, we don't put anything in, so it's going to stay the same. But then right at this point right here, we're going to withdraw some money, which means we are decreasing how much we have at that time. So decrease. After that, it's going to stay the same because again, some time passes and we don't touch our checking account. Again, right here, we're going to deposit some money. So that means we're increasing how much is back in. And then we're going to stay the same. So we stay consistent. We increase how much is in our account. We leave it alone for a while. We take some money out of our account. we leave it alone, don't touch it, then we put some money back in, and then we don't touch it again. So let's look at this one. This deals with weekend temperatures and the time. So as the time goes on, it looks like our temperature is increasing. So that increases. It reaches the peak and it starts to decrease. Again, it peaks down at the decrease and it starts to increase again and then decrease. So warmer, starts to get cooler, then it starts to get warmer again, and then it starts to cool off. A student used a graphing calculator, a data collector, and a motion detector to make the graph below. It shows a classmate's distance from the motion detector. So here is where the motion detector is. This is the time in seconds that the student was moving. This is how far away they are from the motion detector. So during which section was the student walking toward the motion detector? So right now at 0, this is where the motion detector is. So at 0 seconds, the student is a distance of 10 away from the motion detector, so pretty far. Well then as time gets going, they are walking towards the motion detector because they're getting closer. If they were 10 away, now all of a sudden they're only 4 away. So the section that they are is section 1. And that is from 0, and then if we look down here, 0 to 9 seconds. So from when they first started all the way into 9 seconds, the student was walking towards the motion detector. During what section was the student walking away from the motion detector? So once it started, from 0 to 9 seconds, they're walking towards the motion detector. Then all of a sudden they turn around, and now they're heading back away from the motion detector. And that is from 9 seconds until, it looks like about 13 seconds. So the first 9 seconds they were walking towards it, the next 4 seconds they were walking away. And which section was the student standing still? That is section 3. In this section, the time keeps moving, but they are still a distance of 7 away from the motion detector, so they have not moved from that spot.